All right, now let's practice some with piecewise defined functions, domains, and difference quotient. So recall from college algebra that the absolute value f of x equals absolute value of x. So if you recall, this was the one that was that V shape like this, but let's see exactly why that is. So let's graph f of x. So more exactly than just a V shape. All right, so I have my x values and my f of x, which in this case is absolute value of x. So if I let x be -1, first of all, what is the domain of this function? Can I take absolute value of 0? Yes. Can I take absolute value of -1,000,000? Yes. So it's going to be all real numbers. So if I let x be -1, absolute value of -1 equals 1. So I have my first point here. If I let x be 0, absolute value of 0 is just 0. So x is 0, absolute value of 0 is 0. So the next point is here. If I let x be 1, absolute value of 1 is 1, and so on. So when x is 1, absolute value is 1. So this is my function f. Okay, so do you notice something about the absolute value? Do you notice that it's different? It has two pieces. So when x is negative, so when x is less than or equal, well, we can include the 0. When x is less than or equal to 0, the absolute value function is just a line. What kind of slope is this? The slope is negative. If I go down 1 and to the right 1, that means that the slope is -1. And what is the y-intercept of this line? Well, it crosses the origin, so the y-intercept is 0. So the piecewise defined function is a line with negative slope, with -1 as slope on this piece, and on the other piece, it's also a line, but with slope 1 and y-intercept 0. So the absolute value function is actually a piecewise defined function. So I can rewrite the absolute value function, absolute value of x, as a piecewise defined function. So when x is less than or equal to 0, so on this piece, we saw that it's a line with slope -1 and y-intercept 0. So it is -1 times x plus 0. I wrote everything. So negative slope, -1, and 0 for y-intercept. And then on the other piece, from 0 to 1, from 0 to infinity, for positive numbers, so if x is greater than 0, it's a line with slope 1 and y-intercept 0. So absolute value of x is basically the line -x when x is less than or equal to 0, or positive x when x is greater than 0. Okay? Now let's evaluate the function, this rational function, at the indicated values. So g of 2, well, is 2 in the domain? Yes. 2 does not make the denominator 0, so it's going to be in the domain of this rational function. So g of 2 is going to simply be 1 minus 2 over 1 plus 2. So it's going to give me -1 over 3. What about g of -1? Is -1 in the domain of this rational function? No. So -1, if I plug in -1 for x, I'll get 0 at the bottom. So I would have 1 minus -1 over 1 plus -1, but this equals 0. So not possible. I cannot calculate what g of -1 is because -1 is not in the domain of the function. What about the function g evaluated at a minus 1? Well, I'm just going to put a minus 1 over, instead of x, I'm going to put a minus 1. So this is going to give me 1 plus 1, 2 minus a over 1 and over a. So as long as a is not equal to 0, I can evaluate the function at a minus 1. Because if a was equal to 0, I would get division by 0. And similarly, I can do g of x squared minus 1. So instead of x, I'm going to have x squared minus 1. and this is going to give me 2 minus x squared over x squared. So again, as long as x is not equal to 0, I can evaluate the function at x squared minus 1. Now find the difference quotient for f of x equals 1 plus x plus 1. Again, why is this going to be important? Well, this question is actually asking you to find the derivative of f of x. You'll find out later in calc. So let's practice. So remember that the difference quotient is going to be f of a plus h minus f of a over h. That's what we decided in here. Okay, so I'm just writing the formula from there. All right, so then let's see, we're gonna do this. The difference quotient is just the average rate of change, and it's going to be f of a plus h minus f of a. So f of a plus h is going to be 1 over a plus h plus 1. So instead of x, I just put a plus h minus f of a. Well, instead of x, I'm going to put a over h. Okay, so I just need to bring to a common denominator the numerator. So I need to multiply this one by a plus 1 plus h plus 1. If I do it to the bottom, I have to do it to the top. And then this one needs to be multiplied by a plus 1 so that they have a common denominator of a plus 1 times a plus h plus 1. Okay, so they have a common denominator now. So what did we have in here? A plus 1 times 1 is just a plus 1, minus 1 times a plus h plus 1 is just going to be minus a minus h minus 1. So if I get rid of what I can get rid of, I get that the average rate of change is just going to be, I have negative h at the top over a plus 1 times a plus h plus 1, and then divided by h is the same as multiplying by 1 over h, multiplying by the reciprocal. So then I can reduce this h with this h, and I get negative at the top, negative 1 over a plus 1 times a plus h plus 1. Again, so this is going to be the average rate of change, the difference quotient for this function at a certain x, a. All right, so we'll practice more with domains and a piecewise defined function. So to find a domain, we have to keep in mind that I can't have negative under a square root, and I can't divide by 0. Okay, so in this case for f of x, the domain, well, I have to put the condition that whatever is underneath the square root has to be positive or 0, and whatever is on the denominator cannot be equal to 0. So let's draw the number line, negative infinity to infinity, and see. So 3 minus x cannot be equal to 0. That means that x cannot be equal to 3. So if 3 is here, 3 is here, x cannot be equal to 3. And then from the fact that 2 plus x is greater than or equal to 0, if I subtract 2 from both sides, I get that x is greater than or equal to negative 2. And let's say negative 2 is here. X is greater than or equal to negative 2. It means it's going to have to be everything after negative 2, but it can include negative 2. So bracket at negative 2 and everything after. So notice, for both of those conditions to be satisfied, it's going to be everything after negative 2, including negative 2, but not 3. So the domain is going to be negative 2. It can't be negative 2 infinity because I have to exclude the 3. So I'm going to put negative 2 to 3 parentheses because it can't be 3. And then union. A web assignment might ask you to use comma instead of union, so pay attention to how they ask for the answer. And then everything after 3, but not 3. So this will be the domain. All right, the second question is g of x equals cube root of x minus 1. Since this is a cube root, I can take the cube root of a negative number. So I don't have any condition in here. X minus 1 can be a negative number. So if I have cube root or fifth root or seventh root, so if the root is even, or it's odd, then there's no condition. I can have a negative quantity underneath a odd root. So for this one, the domain is all real numbers. What about this one? Number 3, again, we have a rational function. It's going to help if we factor, because the condition for a rational function is that the denominator cannot be 0. So I need to find the roots of this quadratic. So I can factor it, x to the 4th over. All right, so again, you have to recall from college algebra. So factoring, what two numbers multiplied together give me negative 2, and added give me 1. So it's going to be 3 and 2, and 3 has to be the positive one. 3 times negative 2 is negative 6, and 3 minus 2 is 1x. So this means that x plus 3 times x minus 2 cannot equal 0. So this gives me that x cannot equal, what can make the denominator 0? Well, negative 3, and x cannot equal positive 2. So if I draw the number line again, and I have that negative 3 is here and 2 is here, for example, so x cannot equal negative 3 and cannot equal 2. So it can be everything in between. It can be negative infinity to negative 3, and then negative 3 to positive 2, and then 2 to infinity. So if you want to write down the domain in interval notation, I need more space. So the domain for this one will be negative infinity to negative 3, union negative 3 to 2, and then union 2 to infinity. All right, then one more example. If I have that f of, this should be f of x, not f of t. Again, this is underneath a square root, because if there's no number in here, it means it's 2. So I must have that whatever is underneath the square root is a positive quantity. So again, it will help if we factor this quantity. So what two numbers multiplied together give me negative 8, and then added give me negative 2. So it will be x minus 4, x plus 2. Negative 2, negative 4 times 2 is negative 8, and negative 4 plus 2 is negative 2. Okay, so I must have that the quantity underneath the square root is greater than or equal to 0. So here you we're going to learn how to solve inequalities later on a little bit, but I can think about it graphically now, because you know that this is a parabola. The coefficient of x squared is positive because it's 1, so it's going to be a parabola going up, and the zeros, the x-intercepts, are going to happen at 4 and at negative 2. So at negative 2, it's going to cross the x-axis, and then at 4. And it's going to be a parabola going up. So I know that this is my f of x. So to solve that f of x is greater than or equal to 0, I'm just going to look where is the graph above the x-axis. So the graph is above the x-axis on this portion, right? And then from -2 to 4 is the graph is negative. The y values are negative, so I'm not going to include that. And then after 4, the graph is also positive. So no to this. So x minus 4 times x plus 2 greater than or equal to 0 happens for x between -infinity and -2. Since it's greater than or equal to 0, I actually have to put a bracket for -2. Because when x is -2, I get that the whole thing equals 0, and I have to include equals 0. And then union 4 to infinity. All right, one last example. We have this piecewise defined function, and we need to evaluate it at these values. So f of -4. I have to look at -4. On what piece is -4 falling into? Well, -4 is less than or equal to 1. So if I let this be first piece, second piece, and third piece, what rule am I going to use to evaluate the function at? Well, -4 falls under the first piece. So that's the rule I'm going to use. So it's going to be -4 squared plus 2 times -4. And this is going to give me 16 minus 8, and it's going to give me 16. F of 25. Well, 25, what piece does 25 falls under? 25 is greater than 1, right? I can rewrite this as x greater than 1. 25 is greater than 1, so I'm going to use the third piece to evaluate the function. So I'm going to use the third piece. Well, what is the rule saying? That if x is greater than 1, the function value is -1. So f of 25 is just -1. What about f of -1? Well, -1, where does that fall under? Well, notice that the first piece says that when x is less than or equal to -1. So -1 falls under the first piece because x can be equal to -1. So this is the rule I'm going to use to evaluate f of -1. So instead of x, I'm going to put -1. And this will give me 1 minus 2, which is -1. And lastly, what is f at 0? Well, 0 falls under what piece? 0 is between -1 and 1. So this is going to tell me to use rule 2. So rule 2, it says that the function is just x. So since I'm trying to find f of 0, the function is going to be equal to, well, this is my x, so it's going to be just x, which is just 0. Okay, later on we're going to learn how to graph piecewise defined functions. So literally this was kind of a review of functions and their domains. The only new things that you should get familiar with is this piecewise defined function and this calculating the difference quotient. Okay, that will be all for the first section of chapter 2.